Okay, so yeah, welcome back. Amazing to see so many people who are new, and also all the regulars who keep coming back. That's definitely a good sign for me. It means people are enjoying these talks, the evenings, and they're at least delivering some value to people. I'm Ed, I'm the organizer here. If you don't enjoy your evening, please let me know, right, so I can make it better next time. If you do enjoy it, let me know as well. That's all feedback is good feedback. And also, if you want to speak, come and find me as well. You don't have to have, the world's best state-of-the-art machine learning algorithm to talk about. It could just be an interesting personal experience or something cool that you've done at work. So yeah, do come let me know. A couple of things to point out. So if you need the loo, they're behind that slightly hidden door where the guy in the blue shirt just came out of at the back. Yeah, and then I guess by nature of us all being in the room, no one's a huge football fan, so you won't be too worried about live updates on the score, which is great. But yeah, thanks all for coming out and picking this, which is definitely going to be more exciting than watching what's probably going to be 0-0, 90 minutes of people just kicking the ball around in defense. So yeah, and then the final thing to point out is just to thank my company, Selden, who helped sponsor this event, give me time to work on it, pay for the food and drink. If you haven't heard of Selden, they are a machine learning deployment, monitoring, and explainability company. So the way I like to describe it is like the last mile of machine learning. So once you've trained your model, now you want to deploy it into particularly like at scale in production. Everything runs on top of Kubernetes, so it's like super scalable. That's basically what we do. So come and chat to me, or a couple of my colleagues are dotted around if you have questions about that. And with that, I'm going to hand over to Daniel Geater, who works at Qualitest and is going to talk to us about assurance for AI. So yeah, I'm just going to unmute you before you start talking. In 1 sec. Okay, I think you're good.
All right, okay. I can kind of hear myself through speakers, so I assume everyone else can hear me too. So thanks, Ed. Thanks, everybody, for joining. So my name's Daniel. I work for Qualitest. Qualitest are a software quality assurance consultancy. We're the world's largest pure-play software test company. And within Qualitest, I oversee the delivery of AI projects. I will try to finish in advance of the kickoff in case there is anybody that wants to go watch the England game. But don't hate me if I don't. So a couple of things about where AI is today and why. Oops, my slides are frozen. There we go. And why the quality of AI and what it means is such a big topic. So at the moment, the adoption of AI is growing. AI as a concept is not new. As a business concept, it's not really new. But the growth it has seen in the last sort of 10, 15, 20 years is incredible. A few statistics, 56% of businesses are leveraging AI in at least one of their functions. That's a 6% increase since 2020. It's starting to affect the margins and the bottom line of those businesses. 27% of those businesses are attributing at least 5% of EBIT to AI alone, and that's a 5% increase itself since 2020. So in other words, it's growing and growing and growing. One of the things that's more interesting, though, is the high performers in AI make use of stronger practices around AI, the risks for testing enablement, and they get better ROI for it. Okay, so a lot of people are using AI, but the ones who put mature processes in around the quality of that AI get consistently better performance. Why is testing AI different? So the world of software testing is not really new, right? We've been doing it for decades, but there are differences in the ways that you test AI and machine learning systems that don't really reflect when you think about how do you test AI and machine learning systems. So traditionally, software takes predetermined input, gives it some rules, predetermined output. If I've got a calculator, I do 3 + 2, I should get 5. There's no two ways about that. AI systems don't quite do this. We give them sample inputs. Sometimes we give them sample outputs, and we ask them to find the pattern. And we don't always know what good behavior should be. And sometimes it's because we have no idea. In the unsupervised learners, some of the more advanced deep learners, we don't have the ability to say, why is this the right or the wrong outcome for this system? Validating that learned behavior becomes a lot riskier than validating taught behavior. We don't have a simple set of rules to follow. And you need very specific skills to do it. Basically, you need to understand the worlds of data science and the worlds of software quality to make the best of both. When you don't get it wrong, I think we've all seen what happens, right? You get inaccurate predictions. We've all had one of those, recommendations from your favorite media platform that just doesn't look like anything you want. We hear the reports about bias and the reputational damage that comes from it. Systems that are predisposed to favor one demographic over another, and the reputational damage, the brand damage that comes off the back of it. Lack of integration, building very, very strong AIs and then having no way to actually plug them in. This is remarkably common. We built a really nice model, but actually we've got no way of hooking it up to the wider system, and it never actually makes it out of the data science setup. The reuse of legacy testing assets and approaches mentioned, AIs behave a different way, machine learning systems behave a different way to program systems. There are certain lessons you have to learn about traditional software quality to deal with the quality assurance of learning systems. There are certain things that have to be treated differently. And of course, the data is continually updating. That's kind of the point of MLOps, right? We have new versions of the model, we have new versions of the data. We need to keep up to date out of time. Otherwise, we start to see drift. If you built a model based on people's commuter habits, working habits, media consumption habits at the back end of 2019, it would have been very, very out of date just a few months into 2020 because the coronavirus pandemic hit. If you build a financial model in around about 2006 that was designed to take advantage of things like, should I give this person a loan? Should I allow them to have what they want? It would have been out of date when the economic crashes hit us in 2007. These are macro scale, but you also see the same thing on a smaller scale. Over time, businesses change the way they work, consumers change the way they consume. We need to keep the models up to date, as well as the fact that the field itself is moving. Every single week, you'll find new papers about better AI, better algorithm, better approach, better tuning, and you need to make sure that you continue to make sure the best of it. When you think about who builds machine learning systems and who's really responsible for quality, it's actually a lot of people. It's not just the data scientist or the guys on the dev team who wrapped the machine learning up in the application that it was then exposed to the world in, or the infrastructure engineer who was responsible for hosting it, or the data engineers who are responsible for procuring the data that then goes through the system. It's all of them. If you're familiar with traditional software development, some of the agile practices have always been, along the lines of quality is everyone's problem. The product's assurance is everyone's problem. The same applies for learning systems. And if you think about who controls what goes on, you've got the product owner who's identified that we've got a system we need to build. You've got the data analysts who are turning around saying, hey, I've got some information here that might be of use to you. You've got the data engineers who are setting up, building, and curating those pipelines to clean your data to make it available. You've got the data scientists implementing the algorithms, trawling through the academic papers to find the best way of converging this particular algorithm to give you a model. The research scientists who are the ones coming in and saying, there is no known way to solve this problem, let's find another one. The machine learning engineers who take those trained models, those trained approaches, and roll them out. The developers who then have to take all of that, wrap it up in whatever application or format you want to expose it to the world in and make that work, whether it's a simple REST API in front of a model or something like a full-fledged app with an embedded system. The data scientists in test who then have to check that everything that was built works the same way. Security engineers who have to make sure that all of that information is being treated the right way, that using a machine learning system doesn't open you up to new challenges, that the model itself is secure against things like adversarial input. Site reliability engineers, a lot of machine learning systems are designed to deal with huge amounts of data. They become vitally important to everything from content balancing to credit scoring to financial assessment. You can make sure these work. The ops engineers who keep this going. Every single one of these people has some form of input into the quality of machine learning system, and it's very, very important that we work with all of them as we go through controlling how do we deal with quality assurance. A little bit lower level, what are some of the things that can actually really go wrong? When we talk about AI and machine learning quality considerations, what do we really mean? So I've grouped these into a few families. This is obviously not the entirety of it all, but it should kind of give you a flavor for what we're talking about. Data selection. Does the data even reflect the domain of the problem? Is it trustworthy? Do we really understand where it came from? before I put all this effort into building training and rolling out a model, am I actually sure the data's good? You know, one of the oldest truisms in all of machine learning is garbage in, garbage out. And then we've got, once we've even got the data, is it free from bias? Is it fair? And so on. What about the model itself? Is the model stable? Can it deal with a certain amount of drift? At what point will it become unmanageable, need retrain, need new updates? Why are we training this kind of model? Why do we always use, you know, I don't know, decision trees for this kind of a system? Why do we always use linear models for this kind of a system? Why do we want to do this? Are we using the right one for the problem at hand, or is it just that it happens to be the one that I, as a data scientist, am most familiar with, and so that's the one I tend to default to? What about multiple parameters, multiple training configurations? Most models are not done the first time you train them. You need multiple epochs, multiple training runs. The validation itself, evaluating the model, performing the fairness tests to understand, did the model generalize well? Did it get stuck on a local maxima, local minima of the problem? Do we actually effectively have a poor fit? Have we tested it with enough different combinations of data to make sure that actually this model will generalize well? Adherence to business KPIs. We're building these models to solve a business problem. The data KPIs are only a part of it. When you say, you know, I've got an accuracy of this, a precision of that, a recall of this, and an F beta of here. Okay, but it was done to solve something for the business. Has anybody thought about how will you validate this as a business test? Okay. Explainability and transparency. Now, there are challenges with certain model types, understanding truly how does this model make its decision. But we can get a certain part of the way. We can start to explain some of what models do. Transparency, do we understand this? If this is making material decisions that are going to affect my customer, do I have the ability to understand why it did it? And user acceptance. The model is only good if people then adopt it. Not only the business KPIs, but the team that are going to use it. Do they really know what they're doing? Are they comfortable with it? If you've implemented a chatbot, do people like talking to it, or would they still rather phone up and get the support engineer? Transitioning the model to production. We can build wonderful models, beautifully curated in our perfect data science environments in the cloud. You know, we've got our libraries and our frameworks exactly where we want them. We've spec'd it with exactly the right amount of CPU, RAM, and GPUs to offload to. Does the production environment reflect that? And has anybody checked it will actually transition correctly, scale correctly? Transition from static data. What do we do when we no longer have those curated sets that we set up at the very beginning of the process? We're going to live data. Non-functional impacts to the model in production. If this model is replacing a traditional piece of software, is it actually as performant as the one was before? Or was the rule-based system or the human that was sitting there making the decisions actually better in terms of how long it took to reach the decision? When you think about those errors, they all group into three families. There's the data errors, the errors that turn up in the data because of where we sourced it from, how we curated it, how we maintained it. You know, the logical constraints, the height and weight that are not possible because you have a person who couldn't live. The nulls, the blanks, the corrupted rows because we've got different systems collating outputs in different ways. The non-representative sampling, the bias, maybe we just don't have enough data in everything we've got to be absolutely sure we can cover every theoretical combination. Do we need to think about, for instance, on synthesis, pad the data? Poor labeling and recall bias. Manual data sets that are labeled badly or that were labeled automatically but incorrectly the first time around can propagate through. Then there's the errors that come from poor AI design. Maybe we chose the wrong algorithm. Maybe we chose the wrong parameters. Maybe we chose the wrong technical KPIs to say this is when we stop training. Underfitting and overfitting, low stability, models that work now but will never generalize to new data, and they're going to need retraining in 3 days' time. Algorithmic and learned bias. You can start with perfectly good data and still end up with a biased model because of the way you've trained that algorithm. You end up with learned biases in the model. Poor feature selection. Did we actually really hit the ones that we wanted to do? And ultimately, unfair model decisions. Are we actually directly testing for the fairness in our models? And then there's the usage and the feedback. Very much the ops side of the MLOps paradigm. The systems and the integration errors, those points where it doesn't quite talk to the production systems. The non-functional issues where it's a great model, but it's just incredibly slow. The attribution bias and the automation bias. I, as a user, don't necessarily trust this model outcome, or maybe I trust it too much. Maybe I'm giving it more than I should in terms of credit, when I would usually, as a person, not allow that decision. Are the users using the model? Are they actually treating it thinking, actually software can go wrong as well? Is this the right way to use this? Drift and degrading performance. To build successful AI and to build AI that we can be very, very confident in the quality of, we can and we should test for all of these, okay? And this is where data scientists in test come in. These are people that both understand all of those quality bottlenecks, and those lists on the previous two slides are not exhaustive, but they get all of those, but they also understand the data science aspects and how these things creep in, and they can design the tests to actually fix this. Whether that is working with the subject matter experts, data engineers, to say, well, what would good data look like? You have this data, but what do you want? Do we need to do synthesis? Do we need to worry about imputation? How do we get the data that we want to make the model that looks how we expect it to? We can build data tests that turn around and say, actually, there's no point running through all the training cycles because I can already tell you that this data is poor. This data will not work for what you want. How do we deal with the AI design errors? Some of these are known, right? The blind validation sets that we can use for KPI checks. But we can also look at specific data, engineering data sets designed to push the boundaries of the model that are not quite representative, because you want to see what does the model do if it's given something unusual. Back-to-back testing. If we are swapping a rule-based system or a human person for this model, would they make the same decisions? Is the AI model performing at least as good as, or is the learning model performing worse? If so, we probably need to go back and think again. The user and the feedback model errors. How will we automate the roll forward, roll back, and system level tests? Are there things we can do on the ops side of the house to let us understand that actually this model is not deployed correctly, it's not working the right way? How will we monitor the model? How will we look for those business KPIs, whether it's, I don't know, how many people clicked the you would like to watch or listen to this, or is it how many loans we gave out this month, or whatever? How will we monitor that to understand the business KPI drift? But the interesting thing is, when you think about the errors in these three families and where they come about, you start to think about where does the effort go into building AI? And the majority of that is also in the data, and then the training, and then the usage. And this lets you come up with a testing pyramid. Now, the testing pyramid has been a concept pretty familiar to software engineers for years, right? Or the unit testing at the bottom, or the integration testing in the middle, or the UI testing at the top. But you can actually start to do this for artificial intelligence and learning systems. You focus a lot of effort on the data testing. Look for the bias, the distribution, the 5 V's, the source data, what's where, the duplication, the imputation. How am I going to deal with the constraints? How am I going to deal with the ingestion and the pipelines? Much like traditional software unit tests, these are fast tests. These are tests that we can do in code on our data sets. And if we know we've done everything we can to keep the data good, it then becomes easier to start to think about, have we built the AI the right way? It becomes easier to turn around and understand, how do we put fairness tests through the model? How do we look at the KPIs for this trained model versus that trained model? The decision verification, doing the back-to-backs, the stability checks, the assurance process where we talk to the data scientist and say, okay, but why have you used this algorithm in this way? And then at the very top, once you know you've got good data, good model, it becomes a lot easier to then control at the system level, how are you using this? How will you performance test this integrated machine learning system? How will you security test this integrated learning system? How will you deal with user acceptance of this integrated system? Then becomes much, much more straightforward. DevOps on traditional software and traditional test pyramids gave us the tools for continuous release and improve. You would go through all of these things, you know? You would start with planning, code, build, test, release, deploy, operate, monitor. It told us how to shift left testing. It told us to take that information and shift it backwards, improve it into the next iterations. Doesn't really work for machine learning though. The reason being the data becomes a problem. You've got to deal with the data curation. You've got to deal with the fact that it's not just about the packaging of the model, it's about the data that fed the model. And this is where MLOps starts to come in. I'm hoping everybody already knew that, or you wouldn't be in this room. We need to add the iterations. So when you think about those three phases on the pyramid, they actually relate to the phases of ML Dev Ops, okay? The data learning and discovery and testing, you can all focus on that as machine learning data testing. The dev side is that middle level. Have you built the application? Have you built the model the right way? Have you packaged it the right way? And the ops side is all about those usage and feedbacks. So if you draw the ML DevOps out, it also aligns with those different windows of testing. So over here, you start to focus on the data tests, the engineered features, the KPIs, the auto-ML techniques, the things that we can do iteratively and very quickly on the data itself to check that we're building models up the right way. In the middle, you can focus on taking your packaged applications, whether you containerize them, whether you put your models in something, whether you put them behind APIs, treating them as part of the wider system, doing those end-to-end flows with the model being just one component, performing those evaluations. And then on the ops side, working with things like container registries, canaries, dark launches, et cetera, to understand if you are okay cutting the model across, taking the feedback, understanding if this model can replace the previous one. Monitoring models, production data sources for the drift, configure the alerting, configure the self-healing. How do we deal with this? How do we deal with that? So conclusions. Learning systems do have their own quality needs. You cannot implicitly trust every model. We've seen that again and again. Data scientists in test have the kind of critical skills to think about each of those phases. Where do I need to focus my testing? Where do I need to focus my assurance efforts? Learning software does have a life cycle, not quite the same as traditional software life cycle, but you can see overlaps, you can see similarities in the process. AI and machine learning errors can be bucketed into errors and we can into areas, and we can use these to build a pyramid and understand how much testing do we need to do at every layer through our process. But it's not something you can do in a silo. You can only build all of those if you work with all the stakeholders. You won't get the business KPIs without a product owner. You won't get those tests you need on the model without working with the data scientists, the research engineers. You won't get those production metrics without working with the ops engineers, security engineers. You won't get those low-level data tests without working with your data analysts, your data engineering team to make sure that you're getting it the right way. In other words, the DevOps process doesn't quite work for machine learning, but the MLOps process does. And it's because you can allow it, all of those different levels of checking. And that's it. I think I've just finished in time for the football. But I do also want to give some time for questions. So if there are any, I will happily take them now. Okay.
Brilliant. Yeah, thank you very much. Let's have a quick round of applause first for Daniel. Great. Yeah, that was really interesting. If you're watching online, just throw your questions in the chat, and I'll come to them in a second. And then I'll go to people in the room. If you just stick your hand up, and then I'll give you the mic so people can hear what you're saying.
Hello. Thank you for the presentation. I really liked it. The question is, do you think it's possible to test feedback loops amongst models? For example, so with feedback loops, I mean dependencies between models. And for instance, you have a model A which generates a feature, and that feature is used in model B. Now, how that, if you change something, if you change something in model A, how does that affect feature B? Or another example, this is an even more hidden dependency. You have two recommendation models, one which recommends books, another one which recommends, I don't know, pens. And for example, the model recommends a book to a user, and how does the user reaction influence the other model that recommend pens? Thank you.
I would probably decompose that problem. I would probably test Model A's inputs and the outputs it creates, and then put a variety of outputs through Model B, because you can almost think of them as kind of an analog to a microservice. You know they're going to pass data from one to the other. You want to test A independently, you want to test B independently, and then you do a thinner layer on the top, which is, okay, having now gone through all of what Model A does, having gone through all of what Model B does, actually the commonalities are here. You know, we're doing exhaustive testing on Model A, we'll have conditions it's not likely to come up with, the things that only 1% of our book and pen purchasers ever do. You can then say, okay, so I'm going to do as much of A as I can, as much of B as I can, and then I will do a thinner amount of A driving B. Very similar to the way you would do, in traditional software, you would think about test all of this unit, do less of the integration, okay? It's more to do with testing MLs as components part of it, but I think you could apply the same layering up and down. Okay.
Hello.
Hi.
Is it working? Yeah, so my question is, what would you recommend for us to, because it's a new field, MLOps is coming up. For ML, we can train our models, we can test on the testing data and everything. What would you recommend is suitable for us to test our machine MLOps skills? Because there are certain frameworks coming up like Vertex AI, Kubeflow, stuff like that. But would you recommend something which is more currently going in the industry, something that is easier for students or maybe practitioners to learn?
I tend to avoid favoring particular technologies. I tend to prefer approaches, because if you favor a technology, you're kind of bound to the life cycle of that. At the moment, if you put everything in Vertex AI and Vertex falls out of favor, what do? I would rather look at, well, how is it doing what it does? I would rather think about the process. What is it teaching me to do? How does it teach me to take the feedback and coach with that? I wouldn't really look to tick off technologies on a box. I mean, if you look at the big frameworks, you've got, I don't know, PyTorch, sklearn, just in the learning frameworks themselves, they all have their relative merits, but they're all building on similar concepts and you can move between them. When it comes to the process of MLOps, I would tend to think about it the same way. Think about what you're trying to do through the MLOps lifecycle, and think about what that means, rather than saying, because I'm using this, I have to test this way. I would treat it as, we want to deal with this level of test quality and assurance. How do we get there? Which tool is the closest fit? Is there a tool that does it all, or do we need to take something and tailor around it, rather than pigeonhole yourself to just one technical offering or one opinionated approaches? Okay.
So based on the step, you're asking us to research on our own, what are the tools available, and maybe try going forward with them.
Not necessarily research what the tools are. I would say determine the process you want to follow,
Yes.
Determine the assurance of steps you want to take, and then look at which tools will best fit you. And if you don't find one that is a perfect fit, look to build around one to get what's right for you.
So first planning everything, then looking for the tools which are better. Thank you so much.
Hi, this might be a strange question, but essentially I kind of wanted to figure out is, can you accelerate the MLOps process by using, say, for example, knowledge-informed machine learning technologies, i.e. like physics-informed neural networks? Thus, you can deal with noisy data sets. So because like one thing you're suggesting is like, you have to curate the data set, but say, for example, you can test on synthetic data sets, add a bit of noise,
Sure.
then go through pre-processing data, and thus you know the structure of your data and then accelerates your whole pipeline.
I think it's a perfectly fair approach. If you understand what those things are doing, and provided you, and it's not always possible, right? We don't have a data set for every possible thing that could ever exist. Certain problems you can only get to the root of with a certain amount of extrapolation. The way I would tend to look at that is, if you're synthesizing, try to ensure that you also, if you can, have an amount of non-synthesized data you can use as one of your checkpoints. But I don't see, I think it's fair to use synthesis tools to build the data up. Sometimes you get better results, sometimes you don't. That kind of depends on which approach you're using. But I don't think it's unfair to try and do it to speed up that earlier stage. Just apply some, common sense isn't the right word, but apply some quality control on it to make sure you don't rely too much on something and then discover that actually you're synthesizing, you're not quite ending up with data that really reflects what you're doing. Okay.
Yeah, that makes sense, because you can sort of like encode sort of like the sort of critical information within your model, or you could sort of like put it within your objective function, so thus you reduce the amount of data you require.
Great. Any other questions in the room? Yeah.
I'm just wondering, can a lot of shops really roll back?
I mean, how often do you see it?
Yeah, we can't.
I think it depends on, it's not as easy as you make it out. I have seen customers that do it, yes. I have seen organizations that can't do it. It's the same as anything. It's the same as any piece of software. So yes, it is possible, but some places can find it more difficult than others. It depends on exactly how immutable your changes are when you put a new model out.
Thank you. In your experience, how does the testing pyramid change over the course of model development?
Sorry, that was quite quiet. How does the test what change?
The test pyramid.
Okay.
How does it change over the course of the development of the model? Like in my domain, usually we iterate over data rather than a model.
Yeah.
And at a certain stage, maybe one part is more important or less important.
Yeah, so I think that kind of comes back to what I was saying here. This part is very much about the data, and that is what the bottom level of that ML pyramid is. I think you will find that you need to put a wedge of effort into the data first, and then there are tests. So you're testing at a kind of throughput throughout, but there would be a lot of tests in your data to mean you need to do less on, for instance, model training and trained models, because that is a part of the process that takes time, right? Waiting for the model to train and converge. So if you're talking more about if the learning system comes from other systems, I would expect they each have their own pyramids. You know, if you're putting a model on top of microservices and one of those services is a data contributor, I would expect that has its own pyramid for its own assurance. But in terms of building a model for a certain rollout, I would say that this is kind of the pyramid put on its side, right? You're doing a lot of testing around the data so that you can do less testing on the trained model, so that you can do the least amount of testing on the full system, because that is where you tend to find the testing is slower and there are more flakiness and complexity into the tests. Did that answer your question?
Sort of, yeah.
You can't look at me like it probably didn't, but I'm happy to talk to you more about it afterwards. Or
Probably depends a lot on the domain. So.
yes.
Okay. And anyone else? Okay, one very quick one from me then, because you talked about bias and fairness quite a lot, and kind of almost throughout the journey that an ML system goes on. Do you have preferred techniques or ways of looking at that? Whether it be, I don't know, I'm guessing early on it's looking at sensitive attributes and whether you pick them as features and things like that. Do you have a framework or something that you can use? Because it's quite a tricky area.
So yes, it's also one of those areas that's kind of still growing, right? The full rule book on how do you fully remove bias, and that is not written. But if you look into it, there are many different types of bias, right? You've got, I don't know, attribution bias, confirmation bias, researcher bias, sampling bias, survivor bias. Each of these things, when you think about them, can be tested for individually. And this is actually one of those points where it's about the data scientists and the testers working together to say, well, what are all of the things that could go wrong? And and then determining it. And there are two ways, or two main areas where you start to apply it. One of them is in the data, and you can do certain types of testing, like you mentioned a couple of them. Do you have any protected attributes? If you have sensitive attributes, do you really need them? In some domains, you will. Like, for instance, medical, there are certain conditions that might be more prevalent in one demographic than another, and so you will need to allow for that. But otherwise, do you really need them? If you do need them, are you checking that you don't have anything? And then that then becomes a very specific test for that particular application that you're doing. The other part of it is then testing the fairness of the model itself, giving it engineered data sets that are designed to stress different things and seeing how does it behave. There's about 10 different types of fairness test that you can go through, which is, let's say we've got a population of a set size. How do they go for this versus this? So 2 places. One is statistically, does my distribution contain things that concern me? The other one is on the model. I can actually exercise it using conjured data or engineered data to say, do you behave the way you should behave? Okay.
Yeah, great. Okay, well, thank you again to Daniel. Let's have another round of applause. Okay, so we're going to take a very short break. Do go and grab another drink. There's still some food, I think, in there. Go to the loo, whatever. Have a very quick chat, but we'll be back here in a few minutes, so don't go anywhere. We've got another great talk coming up. Thanks.
How do I exit this streaming thing of yours?
I haven't done a presentation since 2020.
Okay, hello. Can I ask you all to take your seats again? We're gonna get started. Here we go.
There is no power, but I have enough battery. But should be enough, but you know, it should be 2 more hours. But oh, it's not okay.
Okay. So yeah, quick thing to announce, which I suddenly remembered from speaking to somebody in the break, is that this is actually the last meetup we're having this year. So I guess Merry Christmas and Happy New Year and all that. But very importantly, the next one, I've already got the date locked down and the speakers confirmed and everything. It's going to be on the 10th of January. So when you come out of all that, those kind of celebrations, and you're back into the really boring January where no one wants to do anything, there's nothing going on, there will at least be an MLOps London. So come along and mingle with people. And you know, if you're doing dry January, you don't have to have a drink. There'll be lots of soft drinks. I'll make sure we over-order on those. So the next talk, we've got Nevin here. Nevin has actually really kind of taken one for the team here because he agreed to speak, and he was going to talk about his company that he was at, Lightning AI. Since then, he's left the company, and he then said, I can't really speak about a company I don't work for anymore. And I said to him, well, okay, how about you put something together last minute and talk about some cool experiences that you've done? And he was like, would that work? And I was like, absolutely. So, because I think a lot of the time we have people come and talk, like Daniel did, really interesting content, right? But he's talking about kind of what, his company do and what they've seen in their experiences. And we've had loads of talks like that. What we get very little of is like people's personal experiences. Here's the stuff I've learned over my last few years, and some things have gone wrong and so on. And so I've convinced Nevin to come and do that, basically. So he's going to talk about everything as a remix, what it's been like working in ML engineering over the last few years. So let's give him a big warm welcome to the stage.
So thank you for a really great intro. It's the best one I ever had. Totally overselling my presentation. So we have a small agenda. First, we start a bit about me, like who am I? Then what this presentation is and is not, in more detail. And then the meat of the presentation, DevOps to MLOps remix. Because there is many patterns which have found in DevOps, but they are still applicable, they are still valid. There is some minor differences. So first about me, I was like a young kid, I was bored. My parents gave me PC, do something. I did some coding. I was good at it, apparently. So I did some competitions. Later on, I studied computer science. For a master's thesis, I did some machine learning for DNA-based caller. After that, I kind of switched and worked more on infrastructure, platform operations roles. Last company, Lightning AI, I was a staff software engineer there, and then I was kind of laid off a few weeks ago. It happens. So, what this presentation is not, it's not some kind of super structured cathedral lecture, I speak, you listen. Like, feel free to interrupt at any time if you have some questions. If you know something better than me, please help me.
I have a question. What was your first coding language?
Pascal, then Logo, then C++.
Nevin, can I ask you to repeat if someone asks a question? So, yeah, please shout them out, but could you repeat them just so that the people online are recording get them?
Okay, so the question was, what was my first programming language? I think it was either Pascal or Logo, I don't remember. One of those two. But then I upgrade to C++, like the horrible C++. It's not like definite do X or else. Context always matter. Like this topic kind of structured some books which influenced my thinking, some best practices, and how I've seen what happens if you don't follow them. How can you fail and be in horrible pains and stuff happens. And the last one is, of course, not answers. I'm not an expert. I'm like, have seen some stuff, but it's not like I've done this for 50 years and I can talk about in the old days when the computers were actually small, big, and the whole rooms, the museums. I still have hair. So this presentation is, as I said, it's a book which influenced my thinking and best practice that I recommend, and things I've seen in practice work or don't work, some kind of personal recollection, and an open invitation for anybody like this young gentleman to interrupt me and ask whatever they want or share their stories or whatever. So like first brain teaser, like when you think about your career, you're all professionals here, when did you start it? Like was it when you were 20, 30, 25, 15, or 0? You were born. Even then you had some kind of skills. You were supposed to breathe on your own. You managed to do that and survive without any apparatus, like all of us here. You had some communication skills. I mean, you were hungry, you need to say, like, hey, please feed me. It was a bit unrefined because we were crying there, and, hey, feed me. But it worked, you got fed. And you could convert some food to nutrients as you grow and improve. And you had your first employers. You have like nice, loving parents. So loving parents, you got many mentoring opportunities, how to survive, go in school, they were organization trying to support you, your growth, literal growth, not just figuratively growth. And the thing is, family in some ways are kind of first organizations you've seen, like the first organizations how things should be. Is the first organizational culture, despite us not commonly thinking about it. So bring us to the first book I kind of like. It's called Life and How to Survive It. Written by 2 authors. One is John Cleese. He's famous from Monty Python crew, so a comedian. And the other is Robin Skinner. He's a psychotherapist. So he knows the stuff, and this guy is putting it in life. And the book is basically a conversation between 2 of them about various concepts. And in it, they talk a lot about how our initial family experiences shape how we should think about organizations and what kind of organizations feel good for us, feel that we belong there, we understand what's going on. For more organizational point of view, more business case, there's from DevOps moment, there is Western organizational culture, where he divides organization in 3 distinct types: pathological, bureaucratic, and generative. There is one type missing, which is completely non-functional headless chicken, for a good reason, because no organization can survive, there is no organization at all. But what he analyzed is, hey, there is organization which are pathological, where everything is about posturing, about power, about cooperation. We don't cooperate, we compete like Darwinism to the extreme, where the messengers are short, and responsibility shrinks, etc. These organizations kind of tend not to perform well. So as we go to more, let's call them quote unquote healthy organizations or families, they tend to perform better. So in the middle, we have more bureaucratic organizations, which are more rule oriented. You have some certainty. If you do X, Y happens. But if you have something super rule-oriented, what happens is there is some novelty. It's like a break of rules. Rules are changing. What do you know? It's kind of an anomaly. These organizations are not as optimal as generative organizations, as Western calls them, which are more performance-oriented. It's like high degree of cooperation between teams, between people. And I like this one. Messengers trained. I remember in all this on the internet, how to get your questions answered. One way, you could ask a question, maybe someone responds. The second way, you say something wrong on the internet, then people correct you and answer your question. So it's kind of this way. You try something, you put some effort, like you make a pull request to some public open source repo, you try, you put effort, you make a mistake, and then the maintainer is like, okay, I'll help you answer this question, etc. So it's quite, it has shown by the research from the authors, hey, it actually works, and it leads to best performances. It's also quite nice. So there's a second book I want to really influence my thinking. When I ask people like, hey, how should a good job look like? What does even good management look like? Everybody I talked to, some really cool people, told me, hey, Neven, read this book. It's literally a blueprint. So the book is called Accelerate. It's an amazing book. And they're more like, hey, we've done research. We literally questioned people. We did some conclusions. The first one is, hey, apparently culture can directly impact two things. Hey, organizational performance, which is, hey, can this organization make its mission? Is it a non-profit for whatever mission that is, or money to earn, profit, whatever? And software delivery performance. And similarly, talking of software delivery performance, from DevOps movement, there is usually 4 key metrics teams observe for developer velocity. The first one is lead time. So from the moment you commit your change to master, how long does it take you to hit production? Is there automation in place? And I think there is a parallel between DevOps stuff and MLOps stuff, because something MLOps is also predictable. The time I try to make a change to a model or a new data comes in, what was the time between this change and the time it hits actual consumers in production? Because small lead time also signifies small batch sizes, small increases, small changes. And there's a small change which is negative, it's easier to roll back than if you bundle a bunch of small changes in one big chunk of a release. Then good luck figuring out which commit actually or which change to your model led to the decrease of performance. It's kind of similar for deployment frequency. How quickly can you deploy your new model, your new software, or whatever? The last two are more operational related. It's mean time to restore. If there is some error with the model, maybe a loss of accuracy, or maybe the whole service goes down because it happens. How quickly can you fix it? And the last one is when you make a new change, a new release, how often does this fail? And apparently, software delivery performance also matters according to the research for organizational performance and non-commercial performance. And they have been questioned like, how can we improve software delivery performance? How can we improve the culture? And they have found some causal links. So, hey, if you do this, things can actually improve in good direction. One of these is using lean management practices. So limiting work in progress. Now this is time for more personal stories. I've been in places where there was always 10 different things to do, and people were being context switched from task A to task B multiple times within a single week. So of course there was many things in progress. It was hard to ever actually complete something. It was literally just a bunch of context switching. And if you look at some kind of architecture of famous load balancers, for example, Envoy or Nginx, they try to avoid context switching as well. Like, hey, if somebody is doing something, worker is doing something, let it finish and not interrupt him unless it's a really good time to interrupt. The second one is visual management, so that everybody is on board. What is the process of when a new feature request comes in, to the time it's implemented, to the time it's deployed? And I found this a really good communication tool for all stakeholders, from product, from sales, from engineering, to understand how does our process work. Because I'm seeing miscommunication when sales ask for a feature or some bug fix. It was unclear to everybody involved, hey, has this been released or not? And this communication can have weird side effects when a customer is asking you, hey, have you fixed it? And the sales or support is like, hey, we have fixed it. And they're like, maybe we haven't fixed it. We have, but haven't released it. It's not a good thing to be. It's kind of dysfunctional because there is a breakage of communication barriers since not everybody is on board. What is our process? The third one, failure for production. It's really important for everybody to kind of be aware of what's happening. I was working for one team, one product for a year and a half. There was no customers, there was no failure for production, and of course the product shut down. We were building 1.5 year, the wrong thing, which nobody wanted. It's a waste of everyone's time. Like, imagine working hard, like doing all these crazy products, crazy ideas, nobody uses it. That's not effective use of time. And the last one is lightweight change approvals. It's more about keeping a record of decisions. So I've seen decisions being made on quick Slack conversations, Slack threads, like architecture decision, or like, hey, do this, do that. And then when people leave the company or new people join the company, they have no information, why, no context, why has somebody made this change? Why has somebody made this commit? And it's really hard to we actually understand what is happening. You have to dig architecturally, and maybe you need to remake the same mistakes as previous people did. So what I've seen work with lightweight, literally, it has to be lightweight. If you require 5 people and 10 people to sign it off, nobody will do it. It will just take weeks and months. So it's either a Notion page, a Google Doc, or a Git repository, few approvals, done. It's more to keep a record for history, for posterity, why was that decision made, and to make sure everybody asks the right question during the development of this. So when we build software products or machine learning products, it's easy just to think about code, but there is code, okay, then there is tests, code tests, okay, there is documentation, code test documentation. But if you operate a service, there is also a question, how do you operate it? What metrics do you monitor this service? What does it mean for this service to be healthy or not healthy? What are the alerts I want to be alerted on? Hey, when I should actually, for this feature, when should somebody be woken up and, hey, this is wrong, this needs to be fixed. What is the priority? And the last one, when something is broken, being fixed, hey, what is my runbook? What is the first debugging steps I can do to verify, to try to patch this fix, to restore the service? So this is from just, hey, build it and other team will take care of it, which is before DevOps, versus, hey, we build it, but we also operate it. And to operate it, we already need to be aware, hey, why was this decision made? Do it this way. And to understand how the architecture of a system looks like. And this is my mistake. Okay. Similarly, this is pretty similar to lean product development, where the work is small batches, so small fixes, small changes. If something goes wrong, it's easier to attribute we change broke stuff. I was working in an environment, we had issues with deployment pipelines. We were deploying once a month instead of once a day or once a week. Once we switched from once a month deployment to once a day deployment, things actually got better. We had less issues, less rollbacks. It was amazing. It was not everybody was stressed about release. Release became less of an issue. Before, when we did once a month deployment, everybody was all hands on deck during release. Please don't break. I want to sleep tonight. Exaggeration. It's similar here to gather and implement feedback. Make sure what we are built, things are used. It's better to have one feature working great versus 10 things working poorly, because when you use something poorly, imagine if you use Slack and it sends 5 out of 6 messages. It's has a super cool features, but it says 5 out of 6. It's kind of unreliable. You always have to double check. Does this actually work? Has this thing actually work? And this brings mental overhead to everybody because it may fail. And if you compound multiple services in a stack, which can fail, you will just increase the probability of a failure exponentially. And the last one from lean pro development is team experimentation, where there is no innovation if you just do what has been done before. So there always needs to be some time to actually learn new things, experiment. In my personal life, right now I'm kind of fired or laid off, whatever. I have actually time to experiment what I want to do. I can have time more to read about MLOps, to read more about DevOps, to read more about AI, to read more about PyTorch. And the same thing applies to teams. There is always hey, this is not pressure to deliver, to have something for the customers, but then it's also, hey, can we improve our development process? Can we improve the developer velocity by making local development easier? Can we improve this new technology? Maybe it can impact our business positively. Without any experimentation, without freedom to experiment, there is no innovation. We're just going to have status quo. And the last thing is continuous delivery. All these things kind of impact this delivery. I have never worked in a place which doesn't use version control, so I have no comments there. I have always used it. I'm pretty sure there was some Dropbox slide with final_1_2. Deployment automation, I worked in a place which have continuous delivery versus those that don't have. I think a good trade-off is to have either continuous delivery or at least some kind of process, how do you deliver stuff, and then automate bit by bit of this continuous delivery process. Because this delivery should be non-event. CI, there was this feature I was working on, I'm part of the team. There was no CI coverage for it. And then 2 months later, this feature broke without anybody knowing. Because it's important once something is built, it needs to be reliable because people will assume it's not working. And those tests are basically guardrails or invariants to code base that this thing is still working. Otherwise, a new developer who's not familiar can accidentally break things without you noticing, without you being aware. So this is kind of pre-runtime checks. Hey, this thing is still running. Also, CI needs to be stable. Trunk-based development. I think everybody now knows that having feature branches is bad. One team I worked in, we were maintaining 2 feature branches for 6 months and cherry picking between them. We were double the slow because of merge conflict, so I would not recommend doing this ever again. Test automation, test data management, of course. Shift left and security, also interesting one. It's hard for somebody externally to audit your platform when you, the developer, know best what are the security issues. Because we build it, we know how to break it, what are the issues. So this is why I found it useful. Somebody from more security experience, a previous company, he was actually looking for the code and kind of educated everybody else in the team, like upskilling them. Hey, you forgot about this. And then every team member from juniors to more seniors become kind of security conscious and had this mindset, hey, this can break. And also I've seen people who are more senior than me working their way by educating the team and upskilling them so that everybody is aware of all these issues and principles. The last 3 are kind of the remaining. One is about loosely coupled architecture, where basically inter-team communication, synchronous, is always a bottleneck. Like there was a shared project, a shared repository, where it took 1 week for another team to approve my team PR. Like 1 week, because they were busy with other stuff, we were not a priority. Which means you have to make a change, you have to wait for 1 week. Therefore, if you minimize how much you depend on external team by loosely coupling with them and just relying on shared contracts, you can move faster by not having to wait for 1 week as often. Empower teams of making their own decisions, because the team knows best what is the context versus being pushed from above, you have to do this. And I like when some things make sense to be pushed from above. Like what I like about approaches like this is hey, unless there's a good reason to use this approach, but there should always be some power for the teams to do it differently. Monitoring, of course, and notifications. Like I said, I've seen much better success with products when you actually operate and monitor the platform and think about it ahead of time versus just putting it in after, because it just works better. And there's the last book I want to talk about. It's from Cal Newport, which is called So Good They Can't Ignore You. In it, he talks about career capital, which is an interesting concept, how to think about it. Because we all, at least me, everybody wants to have a nice job, a good job, which has great autonomy, great stuff we do on fun projects. And this is kind of rare. It's not every job is like that. So he hypothesized that we have to have rare and valuable in return, which means, hey, we have to have skills. We have to deliver and deliver and deliver and make our stakeholders happy. And that's how we gain more autonomy. And I think this is kind of fractals all the way down to the teams. Because sometimes I was working on one team which was kind of in a bad position because they were afraid they couldn't deliver. And it's hard to argue for some changes if people don't listen to you because you don't have reputation of being able to deliver stuff. It's always focusing on things that matter and understanding. Okay. And this is the end of my presentation. And this is a bunch of references.
Oh, wow, you have loads of them.
You have to have references.
Okay, yeah, thanks so much, Nevin. We'll do Q&A for people who didn't shout out in the middle, even though you were supposed to.
Yeah. Trunk-based development.
Oh, okay, yeah. The question was, what is trunk-based development?
So basically, a trunk is a top commit of master. That you have just a single branch. Imagine like a tree. It has a big trunk, and there is no long-running feature branches. Because what happens if you have a long-running feature branch, I'm talking about weeks or months, it's almost impossible because those branches diverge over time. It's impossible to integrate them together. There's a bunch of merge conflict, it's a bunch of useless work. So what people usually do, we included, you just merge as soon as possible, but if the feature is not ready to be released, put it behind a feature flag, either an environment variable or something, so you can enable it and disable it on demand. No. So the feature itself is usually feature flagged. So it's usually disabled on production, but on staging you enable it to do some testing, or locally you enable it to do some testing. So you develop feature commit by commit, but while still keeping everything in a single trunk, in a single branch, to prevent these merge conflicts and to prevent hard way to integrate it. Because as you develop a feature, you might refactor some function. But if a trunk has this function, you have a merge conflict. This will just get worse and worse. As I told you, 6 months, 2 branches, bunch of merge conflicts, not fun.
Cool. Any other questions? Cool. Yep.
You mentioned a metrics which I don't remember the name.
Dora.
What's the ideal time from the moment you commit something and it reaches the production? Like the customer, what should be the ideal?
I would say it depends. Like if you look at Google, they did a bunch of research about this. So if you can, I can Google it, but I think ideally like 1 hour, 2 hours, maybe even less. Like the faster you can get it, the better. It's not like hard limit.
Yeah, I was going for like an hour, in between hours versus days. It's not minutes and hours.
If you can do it in minutes.
Answer. I know a lot about Dora metrics, a great reference. So with the book, what they said is they looked at elite performers, high, medium, and low. And elite performers were an hour. And then it was like an hour, days, weeks, months. So for the low performers, they hit commits, and then it was, weeks or months. And I speak to a lot of organizations. I've had some say to me, oh yeah, we do it in 46 minutes, which is really, really good. But you have to look at all 4, because the bottom one, which is change failure rate, their change failure rate, which you want to get between 0 and 10%, was 60%. So it meant that over half their changes were failing. So actually that 46 minutes becomes 5 days. And then I've spoken to other organizations, I tell this story, and then they're like, 46 minutes? We'd be lucky if we're 46 days. So it's a real variance everywhere.
Yeah. So it's always look things into context, not just a single metric, because it's easy to game a single metric.
Great. Oh, I've got to run all the way to the back. Give me a sec.
This is kind of a broad question, but you talked about empowering teams. So one of the best ways to do that, we're finding the place that I work, is tooling, custom tooling internally.
Okay, maybe just to give context, I was never a manager. I was always an IC, individual contributor. So I'll give from my perspective of empowering teams. My perspective is, hey, teams should make decisions on their own as much as possible. And if you're a platform team, your tool should be self-service as much as possible. They shouldn't have to create a ticket for you to provision anything. Hey, we offer Postgres or deploying models of serving models or training models as a service to other teams. We operate this service, it's self-serving. And teams can choose, they can choose if they want to use your service, or they can choose if they want to use AWS SageMaker. It's up to you to make sure it's good for their use case. It shouldn't be forced upon them, hey, they should use your tool because it's internal.
No, I agree. I was just asking if you have any recommended areas or subjects that should be automated within the team to increase productivity for a researcher or an analyst. Or an
what is your
MLE, for
bottleneck?
example.
What is your pain point?
Sorry?
What is your pain point? It depends.
The minute tasks that cause a lot of friction, it's the things that you spend 5 seconds on, but you do them 20 times a day, for example, and that time accumulates and wastes a lot of business hours.
I mean, first, can you eliminate it? If you cannot eliminate it, can you automate it? If you cannot automate it, I mean, there's not much you can do.
It's a broad question. I understand. Thank you.
Any more questions? Oh, they're coming thick and fast now.
What's your plan now for the next couple months?
Well, after I got laid off, I was a bit on overdrive mode, and I interviewed everywhere for 1 week, 2 weeks, and I was exhausted. So my plan is not to chill for 2 weeks or 3. It's winter holiday, apparently, because everybody is slowing down. It's December, hiring is slowing down. So probably rest until the end of December. I have a few leads in the pipeline. And then from January, trying to find something.
As you can see from the slide, is open for work and snap.
I mean, I have a lot of time to interview, like lead code, system design.
He was also reading books at age 0, so that's got to count for something. There was a question over here. Yeah.
I also really like Cal Newport's book. When you're thinking about developing rare and valuable skills, And then if we think back to Daniel's slide earlier, where he kind of showed all the different skills that come together in MLOps, how do you think about developing, depth in one of those areas versus breadth for an MLOps engineer?
I remember from university days, there was this guy, he was Prodecan, name English, like literally senior academic official. He talked about educating us students in a T-shaped model, where you have some breadth, you have some depth expertise in one area, but you also have breadth. Let's kind of think about it. How you do this in practice, you're aware of Cal Newport's deep work, where I guess you practice depth in something you care about. But there's also like just scrolling through LinkedIn or Twitter or Feedly. I use Feedly as my feed reader. I subscribe to a few blogs I care about, which are not spammy or just kind of give me a brief overview of what's happening. This is how I gain breadth. The second way I gain breadth is just going to talking to people and listening what they say. I'm kind of extroverted, so it helps.
You're at the right place, right? You're literally here learning new stuff. It's going to broaden your kind of depth of knowledge, but then you can also kind of hone in on what you find interesting.
Like, for example, everybody talks Kubeflow. Like, go read Kubeflow documentation, try it out for a few days. It will give you breadth. You won't become a Kubeflow expert, but you will see why people use it. How does it fit in your toolbox?
Hi. So in your years of MLOps, I'm just curious, have you noticed any sort of consistent pain points that you might be able to commercialize and thus maybe leverage a startup? Because I'm noticing...
Not yet.
Fair enough.
Yeah, I'm not sure you want to create a new MLOps startup, given how many companies there are already in the space. Like, I'm sure people in this room will resonate with the idea. I can't talk because I work for one. But there are literally hundreds and hundreds of tools out there. It's a bit of a minefield to figure out what you actually want to use and which of them are good and so on. Yeah. Any final questions? Okay. Well, another round of applause then for Nevin. Final reminder then that the next one will be on the 10th of January. So put that in your calendars, or just keep an eye on the meetup page. I'll publish it in the next week or two. But we had the venue for a while, so please stick around, mingle. One of the most valuable things of this is just being able to chat to other people who do similar jobs to you, and sharing experiences, having a drink if there are any left, or whatever else it is you want to do. Enjoy the rest of your evening, and I'll see you next time. Thank you.